My name is Frederico Robledo. I am meteorology from the University of Buenos Aires and the National Research Council of Argentina. And in this presentation, we show the work of the Anticipando la Crecida project, anticipating the flood project. Since 2013, we work different institutions from the National Scientific and Technology System of Argentina. We work together with local governments and local communities to co-produce knowledge about weather impacts. We work with different sectors, for example, small farmers from different areas of Argentina, and also with the emergency sector in different cities of Argentina. This is a collective work. In this case, I have this exposition. I made this exposition, but we work with Nadia Testani, Diego Moreira, Camila Prudente, Silvina Sosa, and they are here also in this workshop Connect. So in this case, we present the Matanza Basin case that we work. So here is South America, and you can see in the yellow circle the area where there is Buenos Aires city, and Matanza Basin is located in La Plata Basin, close to Buenos Aires. More than 5 million people lives on the riverside of the lower and middle Matanza basins. This represents around 15% of the population of Argentina. The most vulnerable populations lives on the riverbed in the lower and middle basin, and it's a plain basin, so the water moves slowly. And in Matanza, for example, there are 4 or 3 floods per year. So here you can see Buenos Aires city in gray, the urbanization, and you can see around Buenos Aires rural areas. So in red, you can see the limits of the Matanza Basin and the different rivers in this case. And here you can see a photo of Matanza River, and there is many population close to the river. And in this river, Diego Maradona was born in this basin and learned to play soccer in a very poor neighborhood close or near to the Matanza River. He born in Lomas de Zamora, Lanús. So this is a small remember of Maradona that we want to make in this situation. So the to put an introduction, the 7 global targets of the Sendai framework. So we focus. This is a figure of this report. So we ask how can we availability and access to multi-hazard and early warning system and disaster risk. So we think that to incorporate the use of local knowledge and practice to complement scientific knowledge in disaster risk assessment. This is what we assume that we propose to work, and to developing a cross-sectoral approach, which should be tailored to localities and to the context. So how we have a second question, that how scientific institutions what put in dialogue with the concerns of local actors. So we make a conceptual frameworks. It's an interdisciplinary project, Anticipando la Crecida. We work meteorologists, oceanographers, hydraulic engineers from physics science, Also, we work together with geographers, anthropologists from interdisciplinary approach, and we dialogue with local governments, local actors, and we construct a trans-sectoriality approach. We build a permanent dialogue environment between the scientific institutions and local actors. And this we made to co-produce knowledge, and we think with this methodology we can integrate notions of climate risk to co-produce knowledge in an early warning system favors its appropriation by the local community. So this is our conceptual framework. And so here you have the components of an early warning system. I think everything knows. So we work in 3 components or 4 components, but focusing monitoring and alerting, knowledge of risk, and communication and dissemination. So we construct as an alternative looking for a new paradigm to work. We make think that the scientific questions could be performed from the researchers and also with the local actors. For what? To guide research issues towards solving specific community problems. So research along with residents of a neighborhood and a local government have 2 questions. We formulate 2 questions: how to anticipate the flood and how do we understand water movement in the territory. So the main focus of this project is to co-produce knowledge with a community early warning system. We propose a symmetry of knowledge between technical knowledge and local knowledge. All this knowledge, they are in the same table, at the same level. There is not any knowledge above or below another. All the knowledge integrated to understand the basin. So we will show some pictures that this work to visualize the different components of the early warning system. So here we start with the community monitoring. We develop with the local actors a community network with rain gauge to monitor the rainfall, with the local government, also with different schools the community, different schools from this area. Here we have 2 schools. You can see in the school number 23 the rivers, one of the rivers close to the area that generate floods. And also we work with community organizations of this area, the local governments, and we make a community training on how to measure rainfall, to compare this information with the monitoring information from technical institutions of Argentina. Also, we have a community monitoring of the water level. You can see there the Matanza River in a normal situation. You can see there the ruler to measure the height of the river. And here you can see a situation that the river grows up 4 meters. This is not a critical situation. Also, for example, in a hospital, we installed a weather station. And for example, we installed another hydrometric ruler operated by neighbors. You can see here a picture of the report in a not a critical situation, but with rainfall, this river go up. So another aspect, that was the aspect of another aspect to construct this early warning system is the risk awareness. So we have a strategy to community mapping. So people build the flood spot, and also they mark flood impact location. You can see here a picture of the community. Is any question? No. And you can see here a community in a school measure precipitation and identify the impact locations. Another kind of reports are the citizens' reports at times of river floods. You can see here a picture of a flood situation, and the people also signalate. You can see here in blue the areas where there is water that impacts in many houses and many in different areas of the basin. And all this information that the people collect in work with the National Geographic Institute of Argentina, we here referencing information co-construct with the local actors and with ArcGIS or QGIS. This is the information that we work with the schools that function as evacuee centers, or with families from different parts of the neighbor that attend the families from the different part of the neighbor attend the schools. So this information we start to represent in ArcGIS or QGIS the different shapes of the local community knowledge. Also, we work with the communication and disseminations with different strategies. Here is Diego Moreira and another member of the group. And here we use WhatsApp to interconnect the different actors of the basin. So the first moment we share official information from the National Weather Service of Argentina, forecast, alerts, etc. And there the community start to report informations. You can see here photos and millimeters of rain. And finally, we construct an hydrometeorological report that it's shared with the community to build the decision making with this information. So with all this information, Nadia Testani, another member of the group, it's calibration the Sacramento hydrological model, validation with information from the community, and this is part of her thesis of undergraduate thesis that Nadia is working at this moment. So here we present one situation. Is between 13 and 17. We have 3-4 days of precipitation, more than 100 millimeters in the basin. The rainfall, the spatial distribution of rainfall is not homogeneous. You can see here in the middle basin close to 200 millimeters, and upper basin 130 millimeters of rainfall in 4 days. So here we have a situation that here we have different days. Here is the two moments of rains that accumulate the rainfall. So the river go up to 2.5 meters. This start have problems in some areas of the basin. And then with the second event of rainfall, the river go up close to 3.5 meters, and another area of the basin hub. So with this kind of information and the report of the people, we construct the relationship between precipitation threshold, river heights, and impact areas. So in this case, in 2018, after the rain, the river started to rise. There were affected areas for 6 days, and the most critical flood in Matanza Basin was in 2015, affect for 15 days, and the river exceeds for 4 meters. So this kind of information we use then for validate models and to understand, and also we share this information with the local actors to understand the river. So the Matanza Basin experience, the local government and the community of affected areas, they got used to monitoring and sharing hydrometeorological information. The local community anticipates the flood, success case with flood in October 2018. The community organized and could anticipate the situation of flooding. And the community, the academic community draws on community hydrometeorological information to validate hydrological models. And the local governments begins to demand information and forecast for quarterly perspectives to plan risk management. So the situation that the government, the local government start to co-produce information of monitoring the basin, they start to ask for more information. So we talk about the information that provides the National Weather Service for 3 months and different kind of products of the National Weather Service. We start to talk also in that point. And finally, the local community knowledge at the same level. There are three strategies that we have. The local community knowledge at the same level as academic technical knowledge. The second one is the collective understanding of the way in which water moves in the territory, intersectoral and interdisciplinary dialogue. So this is the framework that we think that favors the social appropriation of knowledge. So, well, that's all. Thank you very much, and we are open to questions or suggestions about the work.
Thank you very much, Federico, for that excellent talk. So I'm quite impressed. So there has been quite some comments already, suggestions where to publish the work. I was going to say this seems like to be a textbook approach of Sendai framework. Yeah, from risk mapping to communication, all on the level of the community. Very impressive. We have a few questions already in the comments, so I'll start with the first one I can make out here. So
I can see the question in.
Okay, so there.
Let me see. I will try to see the question in the chat. Let me see.
Yes. So the first one is from Mohan. So I can also read them out. So it's basically about everybody seems to give them some love for Maradona. Obviously.
May I say something,
is,
please? Hello.
Yes, sure.
Okay. Thank you for the opportunity. So actually, I am Dr. Mohan Kumar Das from Bangladesh. So Maradona is very popular in my country. I'm very impressed by the presentation from Argentina. It is really very praising work. So just for my curiosity, I would like to know, for the very precise event, localized event, like tornado, mesosphere convective system, and some hydrometeorological phenomena like flash flood, how the warning is reliable for the community, and the citizen science, how people are rely the warnings and how they understand the warning and how it affects to the people, and how that they are taking some action or measures from their learning. So thank you very much for the opportunity. Over.
Thank you, Mohan. We know that in Bangladesh, you also appreciate Maradona. So
yeah, he's very popular in my country.
Yes, we know. And so about the extreme events, if I understand the questions, the National Weather Service is the institution, the official institution that generate the alerts and the early alerts to extreme events from like strong winds, etc. And it's a challenge for the community that start use the information of the National Weather Service because it's that we observe that the information of the National Weather Service is the better information to anticipate extreme situations. There is an institution that have it's all the time generate, observe the situation with radars, etc., all the sensory monitoring. So the people start to use any apps of meteorological weather, but that information is the apps information from you can find in internet is not very strong to analyze the concrete or specific events, but the information from the National Weather Service, it's worked very well to anticipate, and the strategy of this project is to put this information of the National Weather Service close to the people in a neighbor, that and help to the interpretation of that information, and we propose to the local governments and all the actors that the better information to use is the National Weather Service information, and not all the apps and etc. that you can find. So our strategy is to put all this in over the table and work in that way. So I don't know, Mohan, yeah, I understand well the question, but
yeah, thank you. Yeah, you nicely discussed the things. Actually, yeah, there is. Yeah, hello. Yes, please.
1 point. We think that at this moment is a problem. All the information at this moment is a problem. Information that we find in internet, because we don't know the source of that information, the confiability. So we identify that a problem. It's really necessary to work with local government that they use the National Weather Service information.
Maybe I can add on that question. We have another one in the chat, but it's connected to the previous question, because I was wondering. It's very important to bring in the community, and they add, of course, a level and bring this national forecasts to a really local impactful level. But I was wondering about the durability of the local system that you built. I saw that you work with the tools that you had available, so transferring doing communication with WhatsApp or other messengers. So have you any experience how durable this is over the time? Can you keep people involved, and then will this still work in a few years from now?
Yes, the strategy to this work was durable. We proposed to local government that they work in this network, and work as the network. We try to work that this network work with the people of the local communities. They generate his information, they make the reports. That is our strategy, and that way, we think that the better strategy for that is that the local government, for example, have a meteorologist, for example, working in the local government, then they can understand the local situation, the local reality of the government, and they appropriate this tool and use. In the case of Matanza Basin, yet there is not a methodology working, but there is Adriana Berra was a local workers of the local government that she have this strategy of monitoring or construct that early warning system with a strong implication in that work. So the strategy is to generate local people that can work in this way, and that is the point that we think is, if I understand the question, the strategy is to generate in the local government the people that can reproduce this by himself.
Mm-hmm, mm-hmm. So there's one last question in the comments. We have the time for it. So the comment was, this is a really fascinating presentation. How do you manage the time spent on communication with the community, collecting data and then sharing it back?
So could you repeat that question? Sorry.
How do you manage the time? Or yes.
Yeah, well, if I can say it out loud, just to say,
Perfect.
I think it follows up a lot on the discussion we were just having, to say that the time, this was a great presentation, and as everyone said before, an incredible project, but not to underestimate the amount of time it takes to have the communication with the community and to receive the reports and also give the reports back to the community. That's quite an undertaking for a project. And I think the question was kind of answered before, that it does need to, it is in itself a project or a huge outreach effort. So I guess that was the question, is how is that time going to be allocated, or that effort going to be allocated? Because it's something to consider in this whole session. It's not a small side thing to have the communication with the community. It is something that needs to be thought out, because it is a huge undertaking in itself, and it's very impressive, this project that was presented here today.
Okay, so the time that spent on communication, we accompany, or when the people in the local communities they I don't have the word exactly where, but they ask for us for information, and so when they ask for us, we give also all the time we give a response. So the strategy here is to in each event of precipitation, the previous moment, during, and when the event is finished, in all the time we focus in communication with the community. Yes, this is much time. We have time, but we are a team. We are. I'm not only here. We have many people working this, so it's a collaborative strategy that the people. We have many people giving response to the local demand of information. So our strategy is to attend when the people of the territory demand information. We go there and give to the people a response and hear, and the strategy is to hear all the time that the territory say. Okay, so all the time we need to focus in that the people need in a local territory. So yes, it's time that we put in there, but we think that give results because the early warning system in communities work, and the local government start to use. It's a strategy to start. But yes, we have many time put in that, in the communication, every time via WhatsApp and calls, and that's a point. It's not one event that we go one time to the local territory and then we know. No, we go 3 or 4 moments of the year. We go to the territory to make special workshops to install, and then via WhatsApp. But yes, the communication is a strategy it's important. Many minutes, hours to put in that, and for resolve that we work in a community collaborative work.
So thank you very much, Federico, for showing us this wonderful example of bringing in local communities.